everyone, and welcome to this very first episode of Maker Show. My name is Sherry Lee, and I'm your host today, together with a good friend of mine, Goran Vukšić. Hi, Goran, how are you doing today?
Hello, I'm great actually. Like after a long time, we finally seen the sky is blue today, and it was a really cloudy the past month. I'm here in Malmo, Sweden, and you're just across the bridge in Copenhagen, so weather is pretty much similar, right?
True.
And yeah, I look forward to the show. This is our first episode, and there will be a lot of cool and interesting projects we will introduce over here. So, Sherry, what should we say about the show?
So, this is going to be a monthly show where on each episode we are going to highlight project that is being done by all of you in the community. And of course, there will be a speaker that is going to the project and talking about all the technical things behind it as well. But in addition to that, you all can also ask your questions and start a discussion among yourself in the chat or with the speaker. Speaking of having the discussion going on, so I want to emphasize that we want to have a real inclusive atmosphere here for everybody. So that's why we want you all to familiarize yourself with our code of conduct, which is highlighted on our main meetup page. But long story short, we just want you to be kind to each other and be mindful. And yes, what else we can add here, Gora?
So, on the Maker Show, we want to highlight projects that are focused on IoT and AI. And I would use this opportunity also to make a call for speakers. Like if you have some interesting project that you've been working on and want to show it, please reach out to us. And that is also your opportunity to get Azure Maker badge. And Sherry will mention more about the badges later on. And also, this is call for you to stay tuned. At the end of our show, we also have a small surprise for you. So, Sherry, who is our speaker today, and which cool project we will see?
So our speaker today is Jim Bennett. He is originally from UK but currently lives in Redmond. He mentioned to us that he also lived in different parts of the world as well, such as Hong Kong, Thailand as well, but currently he is in Redmond. He also works at Microsoft and the developer relations team. And specifically in academia team, where he's creating a lot of cool content focused on IoT for students and faculty. And that is how I got to know him as well, because I read one of his articles and I just said that, wow, this is really good to be highlighted in our very first episode, and we can start everything with that. And in this show, what he's going to do is that going to show us that how he wired up his Christmas lights to Raspberry Pi, and he controlled it with a Azure IoT center, and he took a no-code approach to create an app where he can turn them all the lights on and off and change the colors. Isn't it super exciting, Gaurav?
Yeah, it definitely is. I look forward to it.
So let's
So,
have him on the
so
stage.
hello,
Hello.
Jim.
How's
Hello,
it going, everyone?
welcome. Yeah, it's good. You?
Yeah, really good. Really excited to be here. Thank you for the opportunity to share an hour with you.
We are glad to have you here and look forward to your projects. So, how is weather in Redmond? Is it any better than here?
It's pretty good. Let me just peer out the window. We've got almost a blue sky. We had a flurry of snow day before yesterday, which was really nice. It's just at about 4 o'clock in the evening, it started snowing, and it was just enough snow to build a very small snowman. My daughter went sledging on one of the little slopes we've got just literally 100 yards away from here, and I think there's still a bit of snow left on a few roofs, and the snowman's still there. So it's kind of nice. It's nice and sunny, but cold. Kind of perfect, crisp winter weather.
So you have the
Awesome.
white Christmas there.
No, I think it's probably going to melt before Friday. So frustratingly, not a white Christmas.
Well, maybe a bit more false. Yeah.
Yeah.
So should we start with our topic today? I would like to remind everybody who's watching that you can ask the questions, type them in, and we will ask them on the way or later in the end. So Jim, stage is yours.
Awesome. Cool. Thank you very much, everyone. So yeah, this is the holiday season, as we like to call it. There's, I think, 22 different holidays across 7 or so different religions and cultures that fall kind of between the November and January time. Now, one thing that seems to be very consistent across a lot of holidays is lights, whether it's things like Diwali, which is essentially a festival of lights, or Christmas, New Year. A lot of these festivals have some kind of lighting, fireworks, and what have you. So I'm a big fan of lighting. I like to light things up. So, and traditionally you would go and buy a string of lights from the shop and you'd wire them up. And it used to be I'd have to go around turning all the switches on, and now I can ask my my Echo device to kind of turn my lights on. But I thought it'd be fun to make something that's a bit more controllable. It's fun to make some lights that I've got a bit more power over. So I've kind of got a little example here. You see these lovely pink Christmas tree shaped lights that I've got going on there. Now, if I decide that I don't like the color, I could say, get my phone out here. So I've got my phone, just playing with my phone, and type in a number, tap a button, and it goes red. And I've got an off button. I tap the off button, lights go off, and I can then say, let's pick another color. So I just type in a code, tap a button, and the lights come on. So I thought this would be a fun thing to do. And my original aim was to possibly do this all around my house. Unfortunately, it hasn't quite gone that far. I moved into a house a couple of months ago, so I haven't had much time to do it. And I was going to start with one initial strip on the outside of my front door. But every time I try and put it up, somebody invites me on a show to show them off. So maybe this afternoon I'll get a chance to put these outside the front door. So how does this all work? So this all works with a mixture of some relatively reasonably priced IoT hardware and a whole lot of free Azure services. So as part of my job, I help students, makers, faculty, anyone in the kind of education and learning space be successful with Microsoft products. And one thing that students are very keen on is how they can do things as low a price as possible. Students are famous for not exactly rolling in cash. So I like to make sure my makes use the kind of cheapest commodity hardware I can find and a whole lot of free services. So everything I want to show today, hardware-wise, you've got to pay. This whole setup is probably $50 because I'm US based, $50 for all of this. And the lights, if you want to add more lights, it's kind of $10-15 for each strip of lights. And I say all the services are free. Now, I will just put up a couple of things. So first of all, this is me. For those who want to get in touch with me, I'm all over the internet at Jim Bob Bennett on Twitter, GitHub, Instagram, LinkedIn. So get in touch, connect. And if you've got any questions about what I'm showing off, just ask, feel free. I love helping people with solving all their various problems. As I say, I focus a lot on the academic space. So if you're a student, you want more help with Azure products, or if you're an educator, you want to bring some of these ideas into your classroom, get in touch and I can help you with that. Now, I'll also put this link up, aka.ms/Jim/Makershow. This link contains everything that you will need to recreate this yourself. So what I'm showing here today doesn't really have any magic behind it. It's all using off-the-shelf components and off-the-shelf Azure services, so you can do this yourself. You need a little bit of Python capability, but you could pretty much copy and paste the code if you wanted to. So don't worry if you've never used this kind of stuff before. This link will take you to all the resources you need to actually replicate all this yourself, whoever you are. In fact, let me zip over here. This is what the link takes you to. So you've got a GitHub repo with all the instructions and then links to all the different bits and pieces that you might want, buying the hardware, setting up the software, more learning opportunities, all there. Follow this link to get all the stuff. So, well, let's get out of slides. We don't care about slides. We don't care about slides. Let's get on to actually doing the thing. And let's start by looking at my hardware setup. So this is the hardware I've got that puts the whole thing together. I've got a Raspberry Pi here. I've got a breadboard here just to illustrate the wiring, and then a strip of LEDs. So we start by talking about the lights. These lights here are W8218B individually addressable LEDs. And these are kind of the cornerstone of lighting. If you do any kind of maker controlled lighting, these are kind of the canonical thing you can use for doing lighting. So what's really cool about these is they are multicolor LEDs. They're RGB LEDs. Each one of these has got the 3 LEDs in there, so you can create any color you like using these different LEDs. You just tell it how strong you want the red, green, and blue signal to be, and that can create 16.7 or something million different colors, which is pretty cool. What's also cool about them is they're individually addressable. So what that means is from code, you can talk to every single light individually. Okay, so the way it's wired, you have on the outside edge, probably can't make it out. This is a red wire, that's positive, and then you've got a ground one there. So LEDs are light emitting diodes. Power only goes one way. So you get the positive terminal. I've got some power coming in. Talk about power in a second. Comes into the red, goes out the black. And then this wire in the middle, this is the control wire, and this is the one that does all the magic. And you can send a signal down this control wire using off-the-shelf libraries to control each light. Now, these lights are what's called individually addressable. So every single light you can talk to using an ID. And it's not like some super secret, 16-character long weird ID. It's literally, this first one is 0, 1, 2. So they're smart enough to kind of number themselves from the connection onwards. And what's cool as well is as you add more, the numbers just go up. So the closest one to your device is always 0, then 1, then 2. And so like my string over here, there's 150 lights here. It goes from 0 down the bottom there up to 149 on the end. And if I were to tack another strip of 150 on the end, it would go from 150 to 299. So you can literally just keep plugging strip after strip after strip after strip and then address them. And then you can say turn light 1 on, light 2 on. Yeah, in this example here, I'm just doing all the lights in one color, but the one I've got down here, you'll see I've got red, green, blue, and I can change them individually. And that makes these really, really powerful. So I can kind of build all manner of animations, patterns, I can have running lights, whatever I want, just by writing the code to address these lights individually. Absolutely love these lights. Now, these are controlled by a Raspberry Pi. So if you've not come across a Raspberry Pi before, they are probably my favorite IoT device on the planet. I love Raspberry Pis. So it's a company set up in the UK as an educational foundation. Their plan was to build small, reasonably priced single board computers that kids can basically plug into a TV and learn how to code. So you buy one of these, it's got an HDMI socket on there, you plug it into TV, plug in a keyboard and mouse, and it's got Python, it's got Scratch, and kids can learn to code. And they started to build a whole load of resources to help kids learn to code. They were hoping initially to sell maybe 10,000 or so of these devices, and I think last month they sold 7 million. In the month. So these are just ridiculous how many of these things they're selling. It's now got to the point where I think it's like 44% of Raspberry Pis sold are actually used in industrial products. So they've even got an industrial version of this that factories, manufacturing are actually using in their products. So it's great because you can get one of these, you can play with it, and then you can take what you've learned and apply that in a real world industrial setting, which is pretty cool. Now, it's a full single board computer. It runs a version of Debian Linux called Raspberry Pi OS. So that's why you can literally plug this into a TV and you've got a full Linux computer. It just works. They've even just released, where is it? Where is it? Put it away, Sue. They've even just released this. I'm sorry, I'm going to do a big shout out to Raspberry Pi because I love this. This is the Raspberry Pi 400. Okay, this is one of those Raspberry Pis in a keyboard. So this is an all-in-one computer. You plug this into your TV, plug in a mouse, and you have got a fully featured powerful computer. Yeah, this should be on your list to Santa. If you celebrate Christmas, this should be on your list to Santa. It's a fantastic device. And these aren't low-powered devices. This isn't like a small microcontroller that's running at like 100 megahertz. This thing has got a quad-core 1.5, I think it is, gigahertz processor. The latest version comes with 2, 4, or 8 gigabytes of RAM. So, you know, they're pretty meaty computers. And so it runs a full version of Linux. So any programming language you want, you can program on one of these devices. I can't be excited enough about just how amazing these Raspberry Pis are. I absolutely love them. Now, obviously, this is quite a big, bulky device. So if you're using something like a Pi to control lights in your house, you may not want the big power draw of that. And so they even sell this little puppy here, the Raspberry Pi Zero W. So it's essentially the same as this, but lower powered. So this little puppy's got a 512 meg of RAM. I think it's got a 500 megahertz processor, nowhere near as powerful, doesn't draw anywhere near as much power. So you can run this off only a few milliamps. And these little ones are about $10, I think, for one of these. Or you're looking at kind of $35 for the full size one. So they're kind of great for controlling everything. And they have these pins down the side here, GPIO pins, they're called, general purpose input output. And you can use these pins to control any kind of hardware that you like. And that's what I'm doing here. So in terms of the wiring, I've got a USB power supply. So it's run off a USB on here to power these lights. You can power a short strip of these lights from the Pi itself, but the power draw is quite high. So if you put too many, you know, if I had to connect all 150 of those and power them from the GPIO pins, it would draw too much power and burn out the Pi. But for 3 pins, you can do it. Otherwise, you need USB power. And there's enough power that comes out the USB socket to power these lights. And so it's kind of weird. I can't power it from the pins, but I can power it from the USB. It's just the way the power works. So I've got the USB power that provides red, black wires. Got to my breadboard here just for illustration, but the red goes to the positive line for the LEDs. The black goes to the ground for the LEDs plus ground on the Pi. And then this green one here goes to the central control wire. And that's connected to the Pi. So the power circuit comes from here. The control circuit is the green in and then back on the black end of the Pi. And that's how I control it. And this is kind of a fairly basic kind of lighting setup, but this literally gives me all the power I need. And what's cool about this as well is the Pi 4, the one I'm using here, very powerful device. I can use this to develop, but it's hardware compatible with the Pi Zero. So I can develop on the Pi 4, and then I can literally unplug the wires from the 4, plug it into my Zero, take the SD card out of here that's got the software on it, put that in my Zero, power my Zero, and I go. I can literally just swap out this hardware. And because it's all driven from an SD card tucked around there, I can literally just swap out the SD card into a different Pi and get going. So I can program on the 4 and then deploy it in my house using a Zero to reduce the power drain. So that's kind of the hardware setup. Next thing I want to talk about is the software setup. Now, these Pis, because it's a full version of Linux, it can run pretty much any programming language you want. And I happen to prefer using Python because it's a nice, fun, easy to use programming language for me. I've done all the hard language in the past. I find doing C++ to microcontroller can be very complicated. All these pointers and stuff kind of gets me scratching my head. I used to be fantastic at it. Now, can't remember. So Python allows me to get going pretty quickly. And so I programmed the Pi using Python. Now, my favorite IDE for doing everything is Visual Studio Code. I love VS Code. If you've not come across VS Code before, it's a fully open source developer's text editor. It comes from Microsoft, but say it's fully open source. So you can just grab it. You can build it yourself if you want to. And out the box, VS Code supports web development, IntelliSense for HTML and JavaScript and debugging. But there's a whole lot of extensions you can bring in to VS Code to allow you to program in other languages and do a whole lot of other bits and pieces. And one really cool feature of VS Code is a thing called remote SSH. And I absolutely love this because remote SSH allows me from VS Code to code on my Pi. So this VS Code window here, you'll see it says SSH 192.168.197.145 up here. That is the IP address of my Pi. You'll see my terminal, Pi at Raspberry Pi. I am connected to my Pi right now. So although this is running on my Mac, yes, I work for Microsoft, I'm using a Mac. This is the new Microsoft. I'm actually coding on my Pi. So if I were to put a breakpoint here and run this code, the code runs on the Pi, the breakpoint gets hit, I can see the values of the code. So this allows me to do all my Python development on my Pi without having to connect my Pi to anything. So if I were to fix this all up, my plan eventually is to put this all around my house and hide this in a crawl space or a cupboard somewhere. I can always connect to it remotely and then debug the code on my Pi without having to physically connect to it. Now, if you do want to code directly on the Pi itself, if you want to plug your Pi into the TV, they've just released a version of VS Code that runs on the Raspberry Pi. So it's a Debian ARM package that runs on the Raspberry Pi for VS Code. So, you can take your Raspberry Pi 400, install VS Code on this, and you've got a full development environment running VS Code on essentially what's a $35 computer or a $90 all-in-one computer. It's amazing. It's amazing. So enough gushing about Raspberry Pi and VS Code. These are two of my favorite things. Let's actually have a look at some of the code for controlling these lights. Now, there's actually a couple of packages that make life easy. So these two pip packages, RPI WS281X and Adafruit CircuitPython NeoPixel, these are two little Python packages that help you control the lights. So the RPI WS281X is the underlying package to control these lights. These are WS2812B lights. That's the package for it. And then the Adafruit CircuitPython NeoPixel is a nice helper library to make the code easy to write. So Adafruit, an amazing company, New York-based, female-founded and led. They sell these as NeoPixels. So it's their kind of brand name for these kind of LEDs. And they've got a great library to make it much easier to control these lights. So if I actually look at my code.
Jim, you got the question. Yeah. Is it possible to run Node.js
on a Raspberry Pi? Yes. You can run. So this Raspberry Pi is essentially a full-featured Linux computer. So anything you can run on Linux, you can run on the Raspberry Pi. You can do Node, you can do Java, Go, .NET, Python, C++, all the languages. It even supports Docker. So you can have a Docker container running there. It is Linux. It is a fully featured Linux environment. So anything you can do on the Pi. So if you decided you wanted to recreate this, but you wanted to do it in JavaScript, you could. There are JavaScript libraries for controlling these lights. If you wanted to do it in Go, you could, but you may have to send the signals yourself. There may not be a Go library for it, but any language you want, you can use on these devices. Really good question. Yeah.
I have one question actually related to that, but is it something like that related to the version of Raspberry Pi you have, or no?
The Raspberry Pis have always been like this. They've always been running a variant of Linux. Yeah, ever since day one. It's been running what used to be called Raspbian because it's a version of Debian Linux. So ever since day one, it's been running Linux. So you've always been able to do that. There have been other OSs, so you can install Ubuntu on there. If you have an older Pi, there's a Windows version you can install on there if you want to. But yeah, it's always been this fully featured device. They didn't want to make it limited. They wanted to be able to install extra software on there so kids can program in multiple different languages. So it's kind of always had that level of support.
Great.
So yeah, so look at the code to control the lights. A couple of packages we're bringing in, board NeoPixel. I then declare my pixels. So I say it's a NeoPixels. It's board D18. So D18 is the pin on the board, which is the one the green wire is connected to. So this is saying that my control wire is connected to pin 18. I then set the brightness of my lights, just do 0.5 because they are quite bright. And then this is auto write flag. And this allows me to say to the lights, set the colors immediately or set the colors at the end. So I've set this to false, which means I can say set pixel 0, set pixel 1, set pixel 2, and then write them all at the same time. Or you can set it where as you do each one, it'll set each one as you go along. So kind of up to you how you want to do it. If you've just got one pixel, you probably want that to be true and just set the color. If you've got multiple, you want them all to light at the same time, you would then do it and then call show to kind of flash it. So I've got some code here. I'm actually going to change these a little bit to be different colors so you can see what's going on. So pixel 0, that's the first pixel. 0, 1, 2. As I say, if I tack more on the end, it goes 3, 4, 5, 6, and so on. I'm saying pixel 0 is going to be 2550, This is the RGB values from 0 to 255. So this is saying full red, no green, full blue. Gives a nice pink color. So if it was just 25500, that would be red. 02550 is green. 00255 is blue. 255 is white. 000 is off. And then obviously you mix and match to get any kind of color scheme that you want. So I'm setting my 3 pixels to different colors and then calling show to light it. What I'm going to do is I'm actually going to run this through the debugger in VS Code, connect it to my Pi. Now, a little tip, I will point this out. The way these lights need to be controlled, you need to run as a super user on the Pi. So you have to actually sudo to run this Python code. So if you're using VS Code, if you're a VS Code person, inside your launch.json, you want sudo true. You want to add that there because it needs to run as sudo to control the lights. So here I am with my code. I'll step through, set the color, set the color, set the color, and then you'll see my color hasn't changed. I then call show. Now you see my color has changed. Yay, it works. Yay. Yeah. So this is me debugging code live on the Raspberry Pi from my Mac. And this is how I can control my lights. Then if I want to turn it off, I've got an off script. There's a fill command that fills it with 000. So I can just run this. If I go sudo python 3 off.py, the lights are off. It's all turned off. It's pretty cool. It's not that much code, really, to control the lights. And then from here, the world is your oyster. So you can choose different color schemes. You can set up timers to flash the lights. All manner of different bits and pieces. If you want them to kind of twinkle on and off, you can kind of do that. It's just however much time you want to spend writing the lighting code. And there's loads of open source libraries that have got some of this code there where you can just say, do some running lights, and they'll do that kind of thing. So loads of pattern libraries that you can just bring in and use if you want to. So this gets me going with lights. I've got some lights. They're kind of controlled by my device, but I want them controlled by the cloud. Yeah, I'm an IoT person, and the I in IoT does stand for internet. So I probably should bring in some internet into this to make it easier. Now, there's 2 internet services from Microsoft that you can use. There's one called IoT Hub, which is essentially the pipe. It's a big pipeline. You put your devices on one end, you put the cloud on the other, and messages go back and forward. And it's all very low level, all very powerful with security, and can manage billions of devices, and it's fantastic. But it's not the most fun one to use when you do an IoT because you have to build all the code yourself. I'm a lazy person. I like it when people have built code for me. I'm very lazy, so I like it when people do stuff for me. And so there's a thing called IoT Central, which is a software as a service platform that sits on top of IoT Hub, and that does all the hard work for me. So I can be lazy. Yay! So let's zip back over to my browser, back to Edge, and this is IoT Central. So IoT Central, so it's a software as a service platform. You go to a website, go to apps.azureitcentral.com, say I want to create a new application, give it a few details, and up it spins, and you've got a UI to control your IoT application. Now, IoT Central is available 3 different tiers. There's a completely free tier, which has, you don't even need to sign up with an Azure account. You just literally say, I want a free tier, and it lasts for 7 days. At the end of 7 days, it goes away, and you can support 5 devices. Completely free, no credit card, no sign up, nothing. If you want something with a bit more longevity, there's 2 tiers, standard 1 and standard 2. And each tier supports, as you go up the tiers, you can get more messages that you can send, more capabilities, and obviously it costs a little bit more. Now, the cost isn't that high because this is designed for thousands, millions of devices, you're looking at, it's like 40 US cents per device per month or something. So it's designed to be kind of scaled up. But what's really cool is no matter which tier you pick, you get 2 devices for free. So if you want to control 2 sets of lights, it's not going to cost you a penny. Absolutely not going to cost you a penny. So 2 devices is free. I've got the device at the back here that controls these lights and the Pi on my desk set up here, and I'm not paying a penny. Well, Microsoft are not paying a penny for this. I'm not using my own stuff. I work for Microsoft. They can pay for it. So IoT Central is designed for you to build these applications. They're based around what's called device templates, which is the contract that your device has with the cloud. It says what data will your device send to the cloud, what data can be synchronized between the device and the cloud, and what messages can be sent to the device to instruct it to do something. So you have a thing called telemetry, which is the data that gets gathered from the device. If you think about the kind of canonical IoT example of a smart thermostat, the telemetry would be the temperature of your house. You then have properties that can be set on the device or the cloud and then kind of kept synced. And so if you update in the cloud, it goes to the device. Update the device, it goes to the cloud. And if the device is offline, when it goes online, it will then sync that value. It's called properties. So again, think about a smart thermostat, that would be the temperature you want your house at. And then you have commands, which are messages from the cloud to the device to tell it to do something. And that can come with data if you want to. And that has to have a response from the device to say, I've done the thing. And that would be a message from the cloud to say, turn your heating system on. So what I'm using for my lights here, I've got a device template called light controller. And I've got 3 of these capabilities. I've got a property, which is the color. So that way, when I set the color on my lights, if my device goes offline, when it comes back on, it can reload that property value. So it kind of stays, it's kind of perpetual value. And then I've got 2 commands, on and off, which, on turns the lights on. See if you can guess what off does. Now with my on command, in my request, I can send the color. So as part of the command, you can send data, and I actually send the color data that goes in. You can also get responses from commands. So you can actually send a command to a device to do something and get a response back if you want. So if the device was to say, yep, I've changed the lights or something like that, you could actually have that coming back. Now you may notice all this looks very uneditable. It's all very read-only, and this is by design. So just a little note about IoT Central device templates. Once they're done, once they're published and they're in use, they are immutable. The reason for this is because if you've deployed all these device templates to 1 million devices, you don't want to go and break them. You could very easily break all your devices by just changing the name of something. And so you're not allowed to. You can create a new version of it. So if you have a version 2 of your device, you can have a version 2 of your template with extra fields, more capabilities on there, but you can't change one that's set because this is being deployed to the world. There are other devices using it. You can delete it if you make a mistake, delete the whole thing, but you can't make changes. It's kind of just protect you from yourself. Now, once you set your device template up, you define devices that use the template. So I've got my demo device here, set up to use that template. And I've got my commands here that I can do stuff with. And this is my device. Now, when my device is set up, if I click this connect button here, this will give me a load of connection details, a primary key, a device ID, and a scope. And this is what my physical device would use to identify itself to IoT Central to say, this is me. This is the security side of it. There's the old joke, the S in IoT stands for security, but Microsoft, we like to make things secure. We pay a lot of money to a lot of people to build great security stuff, so we like to be secure. And so we have these values. And yes, me broadcasting these values over the internet may not be secure, but guess who's going to be deleting this device at the end of the show? So you can't hack my Pi. So I use these values in some little bit of code in my Pi to control it. And then these are my commands that I can then run. So if I just type in a color in here, FF00, let's go back to my other device, the one that's behind me. And if I go FF0000, the way I've set my commands up, we'll look at the code in a sec, is R, G, B. B. So FF for red, 00 for green, 00 for blue. If I run this, you should see the lights have gone red. And if I run the off one, the lights go off. Let's go back to my favorite color, this nice kind of pinky purpley color. So this is where I can set my commands, and I can play with them here to send data to the device. Now, the code for doing this is a little bit more advanced. First of all, I need to bring in the Azure IoT device package. So IoT Central, IoT Hub, we have a whole load of SDKs for this available across multiple languages. Yep, for the Node.js person, we have JavaScript languages for this, JavaScript SDKs, sorry. We have Python SDKs, C# SDKs, you name it, we've got an SDK for it. And if we don't, there's a REST SDK that you can use to cover all the cases. Now, the thing about these SDKs is that they all support IoT Hub, it's kind of the underlying technology that IoT Central sits on, but they don't all support IoT Central. But because Central is built on Hub, you can control IoT Central applications without via IoT Hub rather than via an IoT Central SDK. So the two parts to IoT Central is actually there's IoT Hub and a thing called the device provisioning service, which is the security service. It's kind of the thing that allows your devices to connect. And they power IoT Central. So as long as you can connect to those two from the SDK, you can interact with an IoT Central application. Sounds a little bit complex, but it should hopefully make sense in a second. So what it means is I can't just say, connect to my IoT Central application. Here's the 3 values from that connection dialog. Do your thing. At least not in Python. In other languages, yes, I can. In Python, I can't. But all I have to do is a couple of extra steps to do this. So I start off by registering my device. I make a call to the device provisioning service, and I give it the 3 values: device ID scope, primary key. These are these 3 values in my connect dialog: ID scope, device ID, primary key. I give it those values to say, hello, this is me. I'm this device. I'm secure. And I register that. And then this comes back with the hub details. I can then connect to the underlying IoT hub that is being used. If I'll just zip down my code a little bit. So I register my device. The result that comes back has got my hub details. I then connect to my hub. So it's not just like one line of code saying connect to IoT Hub. It's provision the device, get back the result, connect to IoT Hub. So there's a few lines of code to connect to IoT Central. Once I've done that, I then connect to a method request received. So in IoT Hub language, you have direct methods. IoT Central calls them commands. They're essentially the same thing. So I connect to the method request received. I connect to the command received, and I put that to a function. This function here, this setup, and I've just got it here in this example. If the method request is on, so if it's the on command, in this case, just light it up. If it's off command, it will turn it off. And then it just responds to say, yep, got a response. And literally, I just sit there and loop. So 100 lines of code, and this is my application. It's just sitting there connected to IoT Central waiting. So in fact, I'll just run this to show you. I run this. So now connect to IoT Central connected. It's now waiting. Go back here. Go back to my demo device. And if I just click run on there without a value, the lights are on 255, 255, 255. I run the off, the lights go off. So just a little bit of code, connect to IoT Central, listen for the commands. And then to bring in the colors, it's basically the same code, except when I process the method coming in, I access this method request payload. And this payload, this is the data that comes in with the method request. So if I type in something here, ff00ff, this is the payload. And so from my method handler, I access the payload, and I use this to set the colors. And I got some code here that will take the color string, split it up into 3 hex values, and light the colors. So if I just run this one, got a second to connect, connected, connected. This now I can put in the color. And you see it will light the color. And I can turn it off. Oh, and I'll turn it off. Cool. But that's how I connect to IoT Central. So not much code. I'm using the Python SDK. I've connected to device provisioning service, provision my device, and then sitting there listening for the commands, and that calls a command handler. So that's got kind of everything I need to control my lights from IoT Central. But I'd like to do it from my phone. This IoT Central SaaS application, it's great, it's powerful, it's not a mobile phone app. If I load this page up, having to navigate around the device it's not fun. So I thought it'll be great to put it on my phone. The ability I was showing earlier, where I can type in a number, tap a button on my type in an RGB code, tap a button on my phone, and have the lights do things. There we go. Goes yellow. It'd be nice to do that. And as I said, I'm lazy. I didn't want to build a mobile app. I can build a mobile app. I used to be known for my mobile app capabilities. I've even written a book on it. But I thought I really can't be bothered. And so I thought I'd use Power Apps. Now, Power Apps, if you've not come across these before, these are low-code or no-code applications. You kind of drag and drop together a whole load of data and services, drag and drop components onto an app, wire them all up together, and build an application. It's designed for citizen developers to automate business processes. I'm sure we've all done those jobs, where you have take this Excel file from here, copy this row from here, put the column here, send the Excel file to somewhere else. We've all done it as in work experience or internships or summer holiday jobs. This is all about automating that so you can get on doing the fun stuff. And what's really cool is it can connect to a whole lot of different things. So it's not just get data from an Excel spreadsheet, you can connect to IoT services. Now you start by defining what's called flows, which are connections between different components. And this is essentially building, come on, load up. This is essentially building flowchart style applications. And so if I wanted to build something to turn my lights on, I can build a flowchart like this. So this is something that's triggered by something in Power Apps, like a button. So something will trigger this off. And then I can add steps to this. And I can put steps in and add steps on the bottom and build up complex logic. I can have if statements and build these really nice flowcharts. But for what I need now, I just want to execute a command on an IoT Central device. And so there is an IoT Central connector. So I can literally go here, add an action. And if I search, I won't actually add it, but I'll just show you. If I search for IoT Central, Azure IoT Central v3. So I can add IoT Central to my application. And I can wire up Teams and other bits and pieces, so I can control this from Teams if I wanted to. But essentially, where I can add an IoT Central application, I can execute a command on it. This executing a command thing here in Power Apps is the same as me clicking the run button over here in IoT Central. So suddenly we've got this capability to build these apps. And so I choose my IoT Central application, I choose my template, I choose my command, which is the on command, my device, and then my color is set as a parameter that comes in. And then once I've got this flow built, I can save this and I can use this in an application. I've got a similar flow for turning it off, but obviously that doesn't take a color. So I went in here, I clicked the plus, searched for IoT Central, these are all drop downs to add the stuff. I typed in my device name and we're done. And that's it. That's the whole thing set up. And then to build this into application, I went to the apps. Unfortunately, because I work for Microsoft, there's about 1 million apps in here. So let's find mine. I went and designed an app. Now you design these apps around what's called a canvas, which is basically the application user interface. So this can be a mobile app, it can be a tablet app, it can be a desktop app. It can be whatever type of application you want. It's basically the UI. The canvas is, basically the UI. And you drag UI components on, arrange it how you like. It's all nice visual designer, and then you connect things. So you'll see when it loads up, this is my application. This application here is the same one. It's on my phone, same application. I went to add, I chose button, dragged it on. I chose text input, dragged it on. And there's, images, camera, blah, blah, blah. All the kind of things you would expect to have on a kind of a WYSIWYG UI editor. It's here. I drag it on. I then click on that. I've got more properties down the side here. I can choose my button colors and border styles and the text, and I can name it. And yeah, all those different bits and pieces that you would expect to do. If you did like the original Visual Basic back in the day, it's kind of like that, where you drag the controls and configure the properties. MFC editor in Visual C++ and all that kind of stuff. It's all that kind of lovely, amazing capabilities. And because it's kind of obvious what everything means, you don't need to be an experienced UI developer to build an application. This is accessible to the citizen developer. You know, people who use computers understand buttons and text inputs. They don't need to know what happens behind the scene, but they could drag a button on and color it and start to put together an application, which is really cool. And so I've got my text input. It's called color input. This is where I can type in the color value. And then in my on button, I want to add the flow. So I designed those flows. I connected up the IoT Central flow to a thingy. That's under Power Automate here. And for my button, I can choose my flow. And I've chosen the turn lights on flow. But literally, this is how I write the code for my button. I take one of those flow charts, Power Automate, and attach it. And then for this one here, the input that gets passed in is color_input.text. So that's the color input. The text property is the value that gets typed in there. And when you do this all in IntelliSense, so as I start typing, it all automatically fill it in for me and show me the text. Excuse me. And so I don't need to know all the inputs. It's all there with IntelliSense. I choose the values and we're done. And that's it. That's literally my application. I can go here and I can go FF0000, which is red, and I can click on. And then behind the scenes, this will connect to IoT Central. I'll send the command. And then in a second, you should see my lights go red. All from this Power App. No code behind this whatsoever. And then once this is done, I can deploy this Power App to anybody in my company. So literally, Sherry, you could go into MS Power Apps, you could find this application and control my lights. Now, you're probably doing that right now, aren't you?
I just think
Yeah, go for it. It's fun. Now, what's cool about this is, this is designed as an enterprise tool that you would build, and you build applications for use in-house. This is not done to be built externally. This isn't an app that I would publish to an app store. This is an in-house application that I would use inside my company. And so it comes as all part of the enterprise licenses that you would buy inside your company, blah, blah, blah. But if you want to learn how to use it, there is a community version for free. So you can sign up for community version. It's what I say community version, it's community account, exactly the same application, community account. And you can build as many applications as you like for you to use. You can't deploy them to other people because it's designed to be just inside your enterprise, but you can play as much as you like. So you can play with this, you can build applications, you can, if you want to automate your lights, you can do that and it won't cost you a penny. So same with IoT Central was free, all this is free. And so literally the whole thing I've put together, I've got an application running on my device. I've done a smaller bit of hardware, plugging in some wires, got a little bit of code running on there, all in with all my code on the final version with all the synchronization of colors. So if I turn it off and turn it back on again, it lights up. Is about 150 lines of Python code. Other than that, it's all no code applications. And boom, I'm done. I get my phone out. It's Christmas morning. I want to go for some nice green lights just to get in the kind of festive spirit. I type in the thing, I tap a button, and then my lights are blue in that case. I wanted green. It helps if I can remember my RGB codes. I do that, bang, we're done. And that is my IoT powered holiday lights. Now, what's also cool, you can do as well, if you want to do a bit extra, if you did, as well as being able to control IoT Central from a Power App, you can also control it from a URL. So you can put together a REST request to control IoT Central, and then if you're like me, you can wrap that REST request up in a Azure function, and then you can make it easier. So I could go aka.ms. Oh, come on, spinning beach ball of doom. aka.ms. Turn. Come on, computer. Term Jim's lights red. I can click on that link, and then just by running that link, there you go. So aka.ms/turn Jim's lights red, green, off will change the color of my lights. So I can do the same thing. Edges ground to a halt. But yeah, so I've now got a URL. So literally, if anybody watching wants to change my lights to green, aka.ms/turn Jim's lights green, you'll see my lights go green. So there we go. That is all my stuff. As I say, all the links there, aka.ms/Jim/make-a-show. That'll take you to here. This is all the code for how to do it. GitHub repo, all the code, all the instructions you need. How to run VS Code on a Raspberry Pi if you actually want to install it. If you've written to Santa and you've got one of these coming, you want to put VS Code in it, instructions there. How to sign up for Azure. If you want to have an IoT Central application, 2 devices are free, but you still need an Azure account. If you're a student, you can sign up for Azure for Students. It's got $100 of credit that lasts you for a year. A whole lot of free services as well for that year. Then every year we just contact you to say, hey, still a student? Okay, have another year. And you keep on getting that renewed every year. If you're not a student, then you can get $200 of $200 of Azure credit and 12 months of free services. Links there for that. Where do you get the lights from? Power Apps Community Plan, where you get free access to Power Apps. The Azure Function app that you can use to control my lights remotely. All the code's there for that. And then if you want to learn more about Azure IoT, we've got Microsoft Learn, where it's online, self-guided, hands-on learning platform. Loads of great IoT content on there. Link there for all that. If you want to get certified in Azure IoT, then we've got AZ220, got links for that. Whole lot of IoT resources for students and educators to use in the classroom, stuff on the Raspberry Pi, learning path on building Power Apps, and then the stuff I'm doing with coding using VS Code remote in the Pi, instructions for that. All of it's there. Head to ak.ms/Jim/make-a-show, get playing. And there we go. That is my lights.
Awesome. Thank you very much. Like, it was really, really interesting. So I see we have a question. Are you also using SAS token for setting up the connection from Power App to IoT device?
No. So it's all authenticated as me. So when I build that flow, when I go in there to the flow and I add the new IoT Central application, what it will do is we'll then log into IoT Central as me from inside the flow designer. And when that authenticates as me, that will then recognize all my apps. So if I go new flow, let's start from a template. Let's just close some of the windows down to get Edge to be a bit responsive. So if I do a Power Apps button, for example, come on, when this loads up. So if I go new step, IT Central, and then execute device command. Now, if I was doing this for the very first time, what would happen is this would then pop up with a login dialog. So I have to log into IoT Central as me. And once I've logged in as me, I can now choose my own applications. So it knows who I am. So I can only choose my applications. So I can choose my light controller. And then once I've chosen that, it'll then connect to that application, down the device templates. That's my light controller. Choose my interface, choose my command. And then the only one I have to type in myself is the device ID. So I don't have to use the SAS token, but it authenticates as me. And then the very first time I kind of run this flow, it'll want to authenticate as me as well. So when I deploy it to my phone, I'll log into Power Apps as me. I run this the very first time, I'll have to log into IoT Central as me again, just to do that authentication level. So it's done based on if I have rights to do something, I can build the flow to do it. And then when it's deployed to the end user, they also have to have those rights. So it's not just that my flow can control this. Because obviously security is kind of hard. If I may have the rights to build a flow and the rights to use the IoT Central application, but another user may not have the rights on my IoT Central application. So when they use it, they will have to log in as well. So it's not done via the SAS token, it's done via login to prove that both the designer and the person using it is fully authenticated. Hope that answers your question. That's probably a long-winded way of saying, no, it's done by login. But yeah, it's done security.
Yeah, but thanks for clarification how it works in details. It's useful to know such things. Okay, maybe just last quick question from my side. So what's the plan? Will you take down the lights together with Christmas tree, or you have an upgrade for that project, next steps or something?
So the next plan is all these lights will come down from here, and then I'm going to buy a whole load more of these, and I'm going to literally outline my entire house in lights. So that's the next plan. Probably, but when it gets a little bit warmer, maybe kind of March, April time, I'm going to outline my entire house in these lights. I'll have to start doing some power considerations because I can power 150 from a USB port on a Pi, maybe not 1,500. So, and I need to buy some bigger ladders as well, but I'm going to outline my entire house, and that way I'll be able to fully control the lights at any time I want. So my daughter, she's 7, she loves Halloween. So come Halloween, I'm going to have orange lights around my house. For Diwali, she's got some close friends who are Indian, so we'll work with them to come up with some cool designs and colors for Diwali. Christmas, we'll start doing. I'm a big fan of kind of the warm white, slightly yellowish light, so I'll do that for Christmas. Maybe for New Year, I'll have to like a countdown to midnight with the lights going. And I'm just going to start building up the different lighting capabilities that I can do. It's all family approved. My daughter and my wife are very excited by having these kind of controllable lights, as long as it's easy. So of course I can just deploy a simple application to them that they can then call to control the light. So and then what's cool as well is once I've got like an Azure function to control it, I can link that up to an Echo skill. So I could then use an Alexa, say, hey Alexa, turn my lights to Halloween mode, and my whole house lights up orange. So that's the plan. So hopefully this time, hopefully by Halloween next year, I better have all that voice control of lights all around my house.
Awesome. Maybe we invite you again to the show just to see
Yeah,
how it
that's what
looks.
I wanted to say. So
Yeah, I have to do it as an outside broadcast. It won't be inside. I have to be outside so you can see it all. But yeah, that could be a lot of fun.
Awesome. Thank you very much.
Yeah,
Thank you.
And by the way, while you were explaining, I kept changing your background color to red and green all the time.
Yeah.
So.
It's pretty cool, isn't it? The fact you can do that is pretty cool.
Yeah, this is very cool. And yeah, thank you very much for a really interesting presentation, I would say.
Thank you very much for having me on.
And Ankit also say thanks for the explanation. So.
You're most welcome. If you've got any questions, reach out to me. Come on, computer. Do your thing. There we go. If anyone's got any questions, just get in touch. I'll gladly help out as much as I can. So I'm Jim Bob Bennett across everywhere: Twitter, GitHub, Instagram, LinkedIn. Come find me, connect, and I'll help out answer any questions you've got.
Yeah, thank you. I guess we should start wrapping as well, since wrapping up, not wrapping. Yeah, I have also a lot of wrapping going on as well since tomorrow is Christmas. So let me share my screen as well here. So the surprise that Gauron mentioned in the beginning is this Azure Heroes Learner Badge that you can all get it. So Azure Heroes, if you're not familiar with the program, is like a token of appreciation from Microsoft to all of you to learn and build on top of our Azure products. And learner is when you are learning something. And of course, now we all learned about the Azure IoT devices as well. So you can just go ahead and scan this QR code, and you will get you need to follow the instruction, and you will get these Azure Heroes badges as well. So this program is built on top of the public blockchain, Ethereum, and to be precise. And in order to have that, you need to have like a digital wallet to collect all of these badges, and it will ask you to use a password. And I learned it in a very hard way that you need to remember that password later. Otherwise, you will lose everything that you have in your wallet. So we have multiple other badges as well, and one of them is actually Maker, which we are going to also give it to you, Jim, for building this project. But we have multiple different badges as well, and you can go to ika.ms/azure.heroes and read all the different badges description that we have. If you want to nominate yourself or one of your friends, you can just go ahead and do that, fill up the form, so they will get it. And we also have, sorry, I need to use my clicker, not the this one because I don't know what is forward and what is backward. So yes, so we have also this map of all the Azure Heroes around the world, and we call it Azure Heroes community, where you can go and add your wallet to this map by using your social media account, LinkedIn or Twitter. You can just connect yourself to the map, and then your name will be listed there. And whenever, of course, you don't want to be listed there, you can just disconnect it as well. And a fun fact, if you go there and right now to go azureheroes.community, you can see there is a person called Goran is listed there, and it always actually on top of them.
Yeah, I wanted to ask, like, is it a bug or feature that I'm always popping up? Like,
I
why?
would say that seems look like it that you have the highest number of badger that anyone could have.
Oh,
So you could.
it's about that. I thought someone wanted a feature for me popping up constantly.
Yes. Yeah, so because we are going to, I mean, there is an algorithm to find out that with the number of the badges and so on, and then you collected these badges in multiple different places, and you've been nominated as well. So yeah, that's why you are the actual Azure heroes, I would say.
Yeah. So we also would like to hear some feedback from us, from you to us, and also to speaker, like how you find the show, what kind of topics you would like to see in the future, and such. So feel free to scan this QR code and to fill in the short form. You can also let us know via in this form if you would like to give a talk, you have some project that you want to show. So reach out. As Sherry mentioned, you will get a badge for that. And also you noticed on our slide the maker show hashtag we are using. If you build some project that is inspired by this show, please share it on social media, put this hashtag, it will get noticed. There is also badge for that.
Yes, you have badges everywhere, so have badger. Yeah, that's true. And yes, upcoming event. As I mentioned, that this show is going to be on a monthly basis, and our next one is going to be in January. So if you want to know the date, the registration page, and so on, so follow us on Twitter on fordevs underscore, and also we're going to mention it there. And one thing also I wanted to mention, if we want to connect to Goran and I, or you want to talk to us, for some reason you don't want to write the feedback on the feedback form, you can reach out to us on Twitter. Both of us, we have our DM open, and that's the fastest place that you can get our attention, to be honest. So yes, so we see you there. And there is also this event coming on. It is related to the topic as well on January 19th. Jim, do you want to say a few words about this event as well?
Yeah. So it's I must admit, I'm not too clued in on all the details of this event, but yeah, we're doing a globally time zoned IoT event. So we've got a whole lot of sessions that we're running. We've got speakers from Microsoft, speakers from the community, covering a whole lot of topics around IoT, and kind of everything's done so that whatever time zone you're in, there'll be a live session that you can watch and get involved in. So we kind of be similar to this, and the fact that be presented live, you can ask questions, get answers directly from experts. And so we've got an amazing range of folks doing these presentations. So whatever time zone you're in, there'll be a live show that you can watch. Check, follow the link, aka.com/allaroundazure-IoT, and sign up, and it should be a fantastic day.
Yes, true. So we hopefully see many of you there. I'm going to actually to learn a lot of things as well, because I started to play around with IoT also. There's a lot for me to learn. And with that, I would just say that thanks for watching us. Thanks, Jim, again for joining us, and see you all next year. And wish you all happy New Year and happy holidays.
Yep. Happy holidays, everyone.
Yeah. Happy holidays. Bye. Bye.